Okay, continuing with the multiple choice section, we're going to do the next 5 questions now. Question 6 and 7 is a combo with the same information provided. This is when we start moving on to red. So the red reaction between bromine and methanoic acid is easy to study. Br2 has a deep red brown color, so this is well, what am I going with that? All right, brownish. And most other reactants and products are colorless or lightly colored. The following measurements are made during a series of experiments between these two reactants. You have the mass of the container, the volume of the gas evolved, and the pH of the solutions. The rate of this reaction could be studied through the use of, now this is a throwback to when I asked you in class, how can you design an experiment to measure rate? Essentially, anything that's changing over time that is realistically possible to measure in the classroom or in a lab, you can use to determine the change in rate. So mass of container and volume of gas evolved kind of go hand in hand. If you have a gas as one of the product, then you definitely can do both of these. So you have CO2 being one of the product here. So that means I can measure the change in mass of the container, and I can measure the change in volume of gas evolved. Now, you can also measure a change in pH if there is a change in the concentration of H plus ions. And I think what's happening here is you're converting this acid into H plus. So there should be a decrease in pH over time because more H plus is being produced from the reactants. So I would say any of the above is the correct answer. Any of these would allow you to assess the rate of the reaction. Okay, and then we have question 7. The quantity on the vertical axis of the graph below might be. All right, this is good. You have a graph for temperature being one of the axes, and you need to work out what that is. So something that is depending on temperature, because your independent variable is always on your horizontal axis, and something that depends on it is going to be on the vertical axis. So we need to think about what out of these variables is going to decrease as you increase temperature. So this means that it decreases as temperature increases. Okay. So we're going to go through the options. The first one, the volume of gas released in a given time definitely will not decrease as temperature increases, because if you increase temperature, you increase reaction rate, and that should increase the volume of gas produced. If anything, it's going to look something like, actually, I reckon it will look something like that, just because it should eventually plateau when you reach equilibrium. The mass of gas released in a given time could be, now I do realize I think I need to go back and probably talk a little bit about this. Anyway, I do need to insert a little bit more information about where the cross comes from, but this is a throwback of the experiment that we did in class when we draw a cross and want to see how long it takes for the cross to become visible or become obscure. And then B, the mass of gas released in a given time. Well, that's going to be similar to A. That's not going to change. That should increase as temperature increases. Time taken for the cross to be obscured and time taken for the cross to be visible. Now, obscured here just means that it's harder to see. But because if you look at the equation, you are reacting bromine with methanoic acid. So it's actually going from brown to clear. So you're not going to measure the time, how long it takes for it to become cloudy or obscured. You have to do the opposite, measuring the time it takes for the cross to become visible. And I think D is the correct answer, because as you increase the temperature, it should take less and less time for you to see the cross. So I would go with D because of that. And that's 7. We're going to move on to 8. I think you remember this question. This is another pretty difficult multiple choice questions, even though I think you guys are very comfortable with red. You can have some nasty questions as well. All right. Yes, this question is difficult, so don't feel too bad if you don't get it. Magnesium carbonate reacts with dilute nitric acid according to this equation in an experiment to investigate the effect of different conditions on the rate of reaction between excess. It's always good to know that it is in excess solid magnesium carbonate and 200 ml of nitric acid. So this is in excess. It does make a very big difference because if you change the amount of the excess, that should not change how much product you get. So you're collecting carbon dioxide gas produced and then plot it against time for 4 different sets of reaction conditions. But you don't know what is being varied here. Which of the following statements is not consistent with the recorded data? So which of the following cannot be the change, I guess? So the first one, the size of magnesium carbonate particles was not the same in all 4 investigations. Okay, that potentially could be one of the changes, especially you can have this between A or B or between C and D. Because when you change the size of the magnesium particles, you're not going to change the amount of products. You're only going to change the rate. So it could be, this is correct, which means not the answer. It could be between A and B, as well as between C and D. Definitely cannot be between A and C though. B, the concentrations of HNO3 was the same in all 4 investigations. Now, I'm not so sure about this because the question already say that the volume of nitric acid used is constant, and the only way to have the different amount of products like this, because A and B you definitely have more CO2 being produced than C and D. The only way for this to occur is if you vary the amount of the limiting reagent, and considering how the volume is fixed, you have to vary the concentrations. I have a feeling that B is the correct answer. I'm just going to circle it right now, but I'm going to go to C and D though. A catalyst may have been used in one or more of the investigations. That definitely can be the case, but once again between C and D or between A and B, because you can see a difference in red without changing the amount of products. The initial temperature may not have been consistent across all 4 investigations. That could have potentially happened as well. So the correct answer here is B. This is not consistent with the data because concentration must vary for V of CO2 to change. And this is because nitric acid is a limiting reagent and the question already specifies that the volume of nitric acid must be fixed. The only way to change the number of mole now is to change the concentration. So that's it. It's really not that bad now you think about it, if you thought about it. Moving on to 9. I can't remember why. What is this? Okay, it is in color. You definitely won't see it. Anyway, so diagram X and Y below shows in graphical form the number of molecular collisions per second against collision energy for 2 different factors that influence reaction rate. And you need to work out what X and Y are. So if you look at X, you can see a change in the distribution of the curve, and that's classic temperature. If you change the temperature, you change the distribution of kinetic energies of particles. So 2 has a higher temperature than 1 because more particles have a higher amount of energy. Moving on to diagram 2, this is catalyst because there is a change in the activation energy barrier. So X is temperature, Y is catalyst, also D. Easy. And I think I'm going to stop here just because question 10 and 11 belong together. So I'm going to do it in the next set of videos. Why did I do that?